Good morning or good evening, wherever you are. To everyone, I, as always, would love to start today with an acknowledgement of the country on which I meet with all of you today. And we acknowledge and pay respect to the traditional custodians of the land and the waterways on which we work from. And we pay respect to the elders past and present, and also extend that respect to Aboriginal and Torres Strait Islanders people here today, and to any of the native landholders from wherever in the world you happen to be. So welcome. We've got a bundle of faces to come and talk to you today. So I'm Jess. If you haven't met me before, I'm the practice lead for experience here at TAD. Later on, we'll also have Harshita Gupta joining us. She is our cohort lead and a principal in the innovation team across BHP globally with us. We also have Kevin Yee, who is our principal product development, and he'll be speaking with you a little bit later about some of the opportunities we're currently talking to the ecosystem about. And of course, the fabulous Holly from Unearthed and also TAD, wearing many hats, and probably all of you have met her already. So I'll talk to the agenda. Perfect. So tick to the welcomes. I'm going to give you a little bit of an intro to TAD for those of you who don't know us already. Then we'll speak to the opportunity streams, more specifically to the copper recovery open call. You'll get to meet our new Essential Minerals Cohort, which I'm really excited about, and then we'll have some time for Q&A at the end. Cool. So whether you have met us before or not, thank you for joining. TAD is all about connecting the opportunities of BHP and our partners to all of you, and creating a fun space where you can do the best work of your life with the variety of resources you need to accelerate your ideas. We are not a one-size-fits-all kind of shop. We want to get to know you and your idea and find a way to de-risk your hypothesis and get it on the shelf faster to create change in the system. So we formed a combined vision of TAD powered by BHP in September, and we have since been refining our work plans around the opportunities that we see as having the biggest impacts. We're in the progress of assessing the capabilities and the technologies that we are aware of in these spaces, so that we can continue the conversation with all of you about how we might work together to fill the gaps. And we've structured our technical focus along 5 programs, which you can see on your screen. Those are there to connect the disruptive external trends that we've been finding with the internal opportunities at BHP. These anchor the forward-looking technology areas into the product roadmaps that we create, so that we can deploy solutions for value both today and tomorrow to both BHP and the mining industry at large, and most importantly, create mutual value with all of you. We have a structured process to experiment and test and de-risk and deploy technology at scale, and we're working to refine that process to support innovators at any stage of technological and commercial readiness, and help them to succeed anywhere along this innovation pipeline. So we look at technology in systems aligned to a concepts of operations framework, rather than just as a discrete solution. And we do that in order to create more systemic, valuable, and sustainable change with all of you. Often, I think what we find is that it's not one new idea that materially moves the needle, but how you combine many ideas to increase the impact through collaboration and integration, and that's what we're here to do together. I feel like I'm talking along today. I might hand over after this. So our experience is all about creating mutual value. I say that over and over because it's really important to us. And connecting ideas and tech and people in new ways with the support that they need to progress faster than they could have on their own. So we're growing. We continue to build the ecosystem and the capability accessible to all of you. So if you haven't signed up to be part of the ecosystem, you can do that on our website. And if you have an idea, you can always submit it through the open house. So any topic at any time, and you'll be assured that you get feedback from the team on what will come next. But now I'm going to hand to Holly, and she'll talk about the specific opportunities for which we're seeking solutions right now, as well as that open-ended call. Thanks, y'all.
Thank you so much, Jess. So there's always quite a lot happening in TAD, which is awesome. So there's lots of opportunities going on. So I'm just going to give you a little bit of an update of all of the different programs and where they're all at the moment. So we currently have, as well as the general open house, which is just mentioned, you can submit any idea on any theme at any time. We have 2 specific open calls at the moment. One which has been open for a month or so now, which is supporting the Jansen Potash project in Canada. If you're on the last webinar, you would have heard from the fabulous Chris and Kathleen, all of the details on the Potash Challenge. So if you'd like to know more about that in detail, please do refer to the video of the last webinar, which we'll send a link out when we send this one as well. So that's still open until the 8th of March, and that is looking for kind of innovative methods for potash drying. The title kind of explains pretty nicely what it is. For those of you that have been following TAD for a while now, you will have probably, I'm sure many of you on the call actually participated in this as well. We are currently going through the biometals and comminution challenge review phase. We were really overwhelmed with an amazing range of companies and researchers and individuals that came through those challenges. So we're very close to finalizing that with the those groups to see who's going to continue moving on to some experimental stages. I won't give you too much information on the recently launched Creative Copper Recovery Challenge because we're going to go into that in a bit more detail. We've got Kevin on the call to give you all of the deep insights into that. And also another exciting thing today, the Essential Minerals Cohort, which was recently announced. And this is covering a range of themes around critical minerals extraction and kind of low impact solutions as well. So you'll get to hear directly from a range of the people in that cohort today, which is really exciting as well. So I will give you a super quick introduction to the background to this Creative Copper Recovery Challenge, which recently launched, and then I will pass over to Kevin to give you way more of the technical details. So Creative Copper Recovery is really around connecting with people who could have novel ideas to develop innovations in heap leaching across the BHP portfolio, but obviously really focused on copper. And this was launched relatively recently, and we are going to keep this as an open call. And leaching, innovation in leaching is a really big domain, particularly in heap leaching, and we understand that there's going to be iterations and more things coming over time. So we'll do a first review on the 19th of April and then start working with people that have submitted by that time, but we will keep the call open ongoing as we expect to have kind of changes in what we might be looking for under the broader heap leaching banner. Kevin will talk more about this, but I think heap leaching is a really interesting area to look at in terms of unlocking the opportunities for low-grade copper assets that we currently have across the whole industry. So there's some really interesting innovation areas to look at to see how we might unlock that. In this challenge, we are specifically interested in how we can kind of increase the rate of reactions, and Kevin will talk more about that, how we can co-recover multiple metals and really optimize the heap leach. So I'd like to welcome Kevin up to give you a little bit more background on heap leaching, copper, and why we need to innovate in this space.
Thanks, Holly. Welcome everyone to this open call. I think it's a very exciting time talking about this topic. So this open call is really linking closely to what Jessica had just mentioned, the TAD broader, I think, product roadmap strategy, resonating in the area of maximizing the value of a ore body and also access the material or the valuable minerals we have never been able to access before. So zooming into copper, really this is the focus of this call. Like if you look at the broader copper industry, I think the copper new deposit is getting harder and harder to find. And all the copper deposit online, which is operating at the moment, facing a similar problem, which is decreasing grade. That put a challenge for people to really want to bring a copper deposit online. Having that economic lens is very important. And the conventional way of unlocking that value through flotation grinding can be challenged because the capex, opex is really high in the conventional flow sheet. Hence, the heap leach is really becoming an option as a low OPEX, low CapEx, and plus the the environmental social value lens is put on top. You could use less water and potentially not generating any tailings. So really, this is a good reason for us to innovating in that space. Zoom into the challenge today a little bit more. I think really we're talking about how we can recover primary sulfide copper through a leaching process. Here on the picture, you can see on the left-hand side is a typical, I think, a heap leach setup. You basically have, have the ore coming from underground. You crush it and agglomerate into a size around 1 to 2 inches, and then you pot them up on a pole. So then you select what we call a lixiviant to basically drip that lixiviant on top of the heap and through the whole heap, and then carrying and dissolving the valuable mineral, in this case is copper, into a pregnant solution. Then you will collect them and have a further process to actually extract the copper. So that's a high level how I think the leach or the concept is working. If you move to the next slide, Holly, in that process, I think what is the real challenge then? So I think there's several of them. I mean, the ones on the screen are just, I think, the examples that we actually trying to guide your thinking, but actually we would like to get all kinds of ideas how we can, how we can unlock the copper from the chalcopyrite, for example, which is a typical primary sulfide mineral. So you have often find a very low grade primary sulfide, which contains a lot of chalcopyrite. And chalcopyrite is very notorious, I think, in the industry, in the sense of being dissolved under different lixiviant, and that's the real challenge: how we can increase the copper dissolution for a chalcopyrite dominant ore body, and also reduce the capital OPEX and also the cycle time as well. So with this as a precursor in your mind, maybe 3 examples on the screen can explain a little bit further for this problem, technical problem. Really, the copper dissolution is a oxidation and reduction process. Often in this process, you involve reagents. Often it's chemical to actually promote that that reaction. Essentially, it's moving electrons from one to another. I think traditional ways to do that is using chemicals, oxidant, and you're often facing a problem of high cost because you're going to use a lot of them. So really, just here, I want to challenge people's mind. Is that the only way to do it? I mean, if it's a chemical, then is there a cheaper chemical we can employ, more efficient as well? Or maybe it's not a chemical solution. It can be a physical or biological, or maybe in other domains that you can bring in the idea to help move the electrons from one mineral to another, and to promote that copper dissolution in the whole process. And also in the economic sense, that needs to be, I think, economic enough for us to employ that methodology to scale it up in a bigger production environment. The other, I think, thing we have to mention is really the kinetics. I think I mentioned a little bit about the cycle time. Often leaching can take a long time because the particle size here we're talking about is 1 to maybe 1 inch to 2 inches. Often takes months, like in a lot of process, heap leaching process, before we can see a good copper dissolution or copper recovery. Hence the importance of increasing the kinetics.
Open and don't work.
So the kinetics really, I think in this sense, we're talking about, the temperature, how you can increase the temperature of a heap leaching process. Where you have a high temperature, normally you have a higher, higher kinetics and reduce the cycle time as well. And that can be in different angles. You can have a bacteria to help that. You can have a physical way to heat it up, but it has to be cheap, right? It has to be economic. So that's one domain. But the last thing I want to mention is really I think what we're trying to promote, especially in the current days of mineral processing, is to have a whole body value lens while you're trying to process the material. That means like you often have whole body, have a copper dominant in the whole system, but often there's like materials like gold and silver, or even rare earths as a small byproduct. If you're just targeting copper, those will go into the waste and be on the pile of dirt and sitting there forever. So I think we need to put a lens on top of that as well today, is how we can not only just dissolve copper, but in the same process, or maybe have one or two processes to work together to not only just dissolve copper from chalcopyrite, but also gold, silver, rare earths, and other elements that can help the world to develop and decarbonize as well. I think I will stop here. Those are really the key examples we're trying to resolve from a technical point of view. But really, I think the problem is there. We want to get people to think from all different angles as well. I think the sky is the limit. So use your imagination and the creativity, and really, really keen to hear what we can get from the broader ecosystem. Thank you, Holly.
Thank you so much, Kevin. I think that was an excellent technical overview to help people really understand the problem and the scale of the problem and the range of opportunities as well. I might, because we're going to go on to meeting some of the cohort members next, I might actually pause now for some questions. So if you do have any questions for Kevin, please either pop your hand up, pop them in the chat, so we can just address those now. There is one, Kevin, for you. I'm not sure if this is a direct one you can answer, from Fernando, which is not specifically about heap leaching, but around if BHP is also interested in new mechanical processes as well for leaching. So they're interested in developing a mechanical process based on liquefaction and inverted leaching. And if there's anything you can comment on that at all.
I think this, we have a problem that we are open to crack that problem from all different angles, as I mentioned. I think I'm not actually very close to the liquefaction of the inverted leaching, that concept, but I'm sure there's probably a group working on that. So as I said, I welcome any ideas from different angles. If you want to reach out us offline to understand a bit more, we can probably be the conduit for you to get that information and connect to you to answer you maybe a little bit better. Thank you for the question.
Again, I don't know if this is something that we can answer now, but a question from Tom on, is electrowinning conducted at the same site as the leaching?
That's a very good point. Thank you for bringing this up. Actually, when we're trying to say we're innovating on the leaching process, trying to dissolve copper from primary sulfide, it's actually not isolated problem we're trying to resolve. You have to put it into perspective of the whole value chain. Like once you leach them, you put it into the pregnant liquor, which is a solution that contains of copper. How you actually can, how might you have an innovative way actually extract the copper from the solution? I think the current conventional process will be so many extraction, ion exchange, but then you have EW process. And those process having the advantage, but also disadvantage as well. Like the EW is very energy intensive process. So how we can reduce the energy consumption in the whole process is probably one of the example for the question we have to answer. So really on this call, we need to think about not only just the copper dissolution in the heap leaching, which is the key question we're trying to answer in this, but also maybe thinking in the next step, if you have any ideas for the following process in EW, how we can innovate and not consume a lot of energy and have a better growth of copper in that process with high quality production. I think that is also welcome.
Thank you. And a question from Tim, which I think I know the answer to, but What kind of modeling do we currently use for heap leaching, and do we have reliable values to understand what's happening in the heap and properties such as I don't know what activities, diffusivities into modeling?
Sorry, maybe I think if I understand the question correctly, is about the modeling, how it actually applied to the heap leaching process. If that's correct, I can comment from
I think so.
the angle. Yeah, so I think modeling is a very important tool for us to employ whatever we're trying to innovating on, and no exception for this open call. I would love to hear ideas, from modeling and simulation point of view, how that can be employed as a tool to shorten the experimenting time, and also the helping us design and monitoring the heap leaching process. For example, you will be able to visualize, understand the lixiviant flow paths in the whole, maybe 10 million ton, 20 million ton of a dirt pile. It's very hard to track them. If you have a system or simulation, or maybe in combination of sensing technology can tell us, can inform the operators of those information, it will be really helpful for them to control the heat process, because heap leaching is very different from the tank leach. Tank leach is in a controlled environment. Often you can cover it up to increase the pressure as well. Well, the heap leach is on the opposite. It's a very large volume, but in the open space. So control can be a really challenge area that we need to tackle. Yeah, I'm equally love to hear any ideas in simulation, modeling, in helping us reduce the technology development time, but also in the implementation stage of the technology, how we can employ them as a tool to actually operating this process properly.
And Kevin, would you say, is it fair to say that in general across the industry, it is pretty hard to monitor the heap leaching or even understand what's happening in the heap easily?
Yeah. Yes, correct. I think, Holly, if you imagine there's often the heap leaching process is like you have a stacker basically constantly stacking the rock on a whole maybe 10-20 million ton pile of dirt in an open space. It's very hard to actually monitor what's happening inside the heaps, which is like 10-20 meters high. So any tools that we can employ will be helpful. Yeah.
Amazing. A couple of questions coming through on the ore types that we're interested in. So are we only interested in sulfide systems, and are we kind of looking at a specific ore body or more broadly for chalcopyrite and primary ore bodies?
Yeah, that's a very good question. I think I'm personally not very interested in the chalcopyrite leaching. It's a very hard problem for the industry to resolve for many, many years, and probably for many years to come as well. I think the industry requires a little bit of collaboration in that space and sharing the information, sharing the knowledge to actually have a proper, crack on that problem. But I'm also conscious that there's a deposit like copper oxide out there, which is probably more manageable for leaching process. But then it's a problem, like as we just mentioned just now, like apart from the hard leaching bit of the chalcopyrite, for leaching process broadly, whether it's oxide or it's primary sulfide, there's always an angle you can look at how to monitor, how to control the process, from sensing and I think simulation point of view, as I mentioned from that angle. I'm not sure if that explains your question, but I think the focus from my perspective is really to understand the chalcopyrite leaching, and also in the broader sulfide mineral system, from the angle of actually dissolving the copper into the solution point of view, because compared to oxide, it's actually relatively harder to do that.
And Kevin, I'm going to jump around the questions a little bit here. And in this one, I'm not sure if you are able to share, but I think for everyone on the call, that there has been a lot of, as Kevin mentioned, this is a problem that the industry has been looking to solve for a long time, and there have been quite a lot of experiments done in this space. So I don't know, Kevin, are you able to comment at all? I know there's some stuff in the public around the results of some of the previous studies in this space, and then how that's kind of, I guess, led to identifying these are still the unsolved problems.
Yeah, I think there's. I think it's because it's a known problem, and I think there's lots of work we can't ignore. I mean, in the broader industry, whether it's from research, whether it's from operations, I think we have to recognize there's a lot of work being done. When we look at this problem, I'm hoping to leverage on the experience we have before and moving forward, but also creating a new line of thinking, new angle of thinking, trying to tackle this problem from different angles as well. You probably, if you're in the industry, and you're probably aware that there's a catalyst people are developing from one vendors, I think pretty well known already. There is like there's internal technology with different mining companies, whether it's BHP or maybe other big companies. They have developed a lot of a process using bacteria or using, I think, the certain characteristics of their specific ore body to actually helping that process. But I think it's fair to say none of them has been really, really successful in terms of recovery and cycle time. They all have, often have a little bit of better recovery, but sacrificing on other things as well. So I think it's still an industrial problem, requires innovative thinking. And if you look at the size of prize for this problem, it's really, I think there is actually lots of low grade primary sulfide deposit around the world, which is uneconomic, unviable through the conventional flow sheet. With the ever increasing pressure on decarbonization for the world, for us to keep filling that copper supply gap, we have to be creative and thinking about how we can tackle that part of the ore body. And this could be a technology. I'm talking about heap leaching of sulfide, primary sulfide mineral, could be a revolutionary technology that we should develop in helping that electrification pathway for the whole human being in history.
All right, we've got a couple more questions coming through, and then I will probably wrap this one up so we can get on to hearing from the Essential Minerals Cohort. And then for those of you that have asked for data, I will follow up with the TAD team afterwards and see what we are able to share and what's in the public that we can share with you, and send out more information there as well. Kevin, a couple of questions on heap leaching specifically on the process. So Matthew's asked about given that the heap is piled up and it's a particle bed, particle size distribution and the gaps between the particles should be important for the flow. Is there a relationship between particle size distribution of the heap and recovery?
Yeah, that's a good question, very technical one as well. Particle size distribution, particle size itself is an influential factor for any, I think, kind of copper dissolution process. As you know, I think logically, if you reduce the particle size, you'll be able to liberate or maybe expose the valuable mineral a little bit better than a bigger particle size. In that sense, you'll have a better leaching performance. But there's also a boundary or maybe a limit on how much you want to reduce that particle size to. In the infinite world, you can reduce the particle size to microns, then you employ tank leaching process, but that is very difficult to process a very large volume. And also there's the energy consumption lens we need to put on as well. So I think broadly industry trying to stop at 1 to 2 inches. But when you crush a particle across the ore body, you always have bigger particles or smaller particles. So often we don't want to have a very standard deviation of that distribution, nice distribution in the outcome in the product, because the small particle will fill the gap of the big particles and actually stop the lixiviant flowing through. So this is actually a step in the processing to actually agglomerate make those particles in, I think, almost even size, so you can pot them up, but still have a gap for any liquid to flow through. So yeah, I think particle size is important in short, but we need to employ, I think, processing methodologies to make sure they're actually serving for the purpose of the process.
All right, I'll take a couple of more quick questions, and then if we have time at the end, we can come back to this, and anything that's not answered, I'll follow up on as well. So a couple of quick, more technical questions. What is the type of lixiviant that we currently use for heap leaching? And are you also interested in dump leach?
Yeah, that's a good question. I think the lixiviant, I think, is a topic. I mean, often people, when we talk about the lixiviant, we think about acid. I think sulfuric acid or nitrate has been used a lot in a lot of the cases. It has its advantage and disadvantage as well. I think here I really want to challenge people's mind whether, whether apart from the if we're using sulfide or sulfuric acid or nitrate, how we can improve the process. But other than that, is there any basic, like a base alkaline environment that we can employ for the process, or maybe using bacteria or using other different type of lixiviant that you can imagine or you can test to help the process? I think that the thinking is really open. We're looking for a very divergent thinking process at the moment before we converge into a solution. So I don't want to really confine people's thought in just acidic. It can be anything.
Hello.
And all right, final question I'm going to put from Gary, which is an excellent one. And then we'll come back at the end if we have time for any more, and if not, I'll answer on email. So question, Kevin, is what parameters do you need to monitor inside the heap, and over what timescale do you need to be able to get updated measurements? And what decisions would you then want to put in place based on the information you're reporting?
Yeah, that's a good question, but I think we dive into a little bit more into the technical details. But I'm happy to comment a few dot points. I think for example, if you want to understand how the lixiviant flows through the heap system, then you might want to employ some technology to understand that. The key thing is to know, like, if there's a blockage, the lixiviant is not getting through the heaps. Apparently, it's not going to get in contact with the valuable minerals. Hence, you won't have any recovery. So I think monitoring blockage in the heap system is very important. That's one example. Of course, with similar to any other mineral processing process, you want to understand the flow rate, understand the copper tenor, understand dissolution rate that can be calculated based on the parameter you're trying to monitor. I think that's that's just a broader system we're trying to. I think we're trying to put it into the whole leaching process once it's in operation. Sorry, I forgot the second part of the question. Can you repeat?
It was just what decisions would you want, or actions would you put in place based on what you're monitoring?
Yeah, I think if, for example, if we talk about those parameters, if you see monitoring the tenor in the copper pregnant solutions, that you can have reactions on, for example, how much acid you're trying to spray on top of the heap, what's the intensity, and you can monitor ions, for example. In certain ore bodies, you have ions like in different forms, ferrous and ferric, and they actually having big influence on the copper dissolution process. Monitoring the ion content in different forms, that can inform you, for example, how much you need to dose for maybe oxidant in this case. But oxidants can be in different forms, as I mentioned. I don't really want to constrain people's thinking, really just in chemicals, but as what are other ways of moving the electrons? I think that's the key. Hopefully that answers your question.
Amazing. Thanks, Kevin. All right, that was absolutely excellent. Lots of information there, and thank you for everyone. For those who haven't got to questions yet, I'll come back to get some of these at the end if we have time. And to Amada, your quick question on how do you present the idea, that is through the Think and Act Differently website. I'll put the link in the chat, and the IP completely remains with you. Onto that question, we can dive into that a bit more. All right, thank you so much, Kevin. Very much appreciated. I can see that Hashida is now with us. So I'll pass over to Hashida to give a little bit of background on Essential Minerals Cohort, and then I will introduce each of the cohort to give you a little bit of background on themselves and what they're working on. So over to you, Hashida. Oh, we can't hear you. No. Okay, I'll do it. Well, I think what Hashida was going to give you a bit of background on the Essential Minerals Cohort, which has recently been announced. The TAD team through the open house ran 3 challenges last year around preconditioning, critical minerals extraction, and the carbon economy, and have formed a cohort with a range of innovators to really deep dive into those topics. So as I say here, the cohort is TAD's way of enhancing collaboration and showcasing progress and learnings and successes of innovators in our ecosystem in a meaningful learning environment as well. And our aim is to try and help innovators test the riskiest assumption associated with the hypothesis they have by providing them with the support and resources that they need to run those experiments. So I am super excited and honored to have a range of the cohort. Not everyone was able to make it today on the call, so I'd like to invite the cohort members that are here one by one. I'll call you up to just give a super brief introduction to yourselves. We'll try and keep it to a minute or so because we're quite tight on time, about what your project is and a little bit about your company as well. So I'm going to just take a punt and see who's on the line. But Oscar from Rockburst, are you here? Or someone from Rockburst? There we go.
Hi guys. Thanks, Holly. My name, can you guys hear me?
Yes,
Okay.
we can hear you.
Fantastic. Yeah, so my name is Oscar Malpica, and the CEO of Rockburst Technologies, and probably the best way to describe our tech, Kevin, by the way, nice to see you again, man, is basically we're breaking rock with CO2. And when you do this is quite significantly different from traditional comminution, obviously. And when you do that, when you break rock with gas, 2 things happen. One, you get less energy consumed per ton compared to incumbent technologies. And 2, because we use CO2, we can mineralize and trap that CO2 in our tailings. So you get both the energy savings and the decarbonization potential in a waterless technology. So I'll leave it at that. Thank you.
Thank you so much. Thank you for keeping it brief. That's very interesting technology, so please go check out the Rockburst site as well. And I'm sure all of the innovators in the cohort will be more than happy if you'd like to reach out to them. So anyone, if you want to pop your email or anything in the chat for people to reach out, please do. All right, is Jacob from Nutratrack on the line?
Hello.
Hi, Jacob. How you going? Welcome.
My audio is working fine.
Yes, it is.
Good. Yeah, so our project is we're using dynamic gas combustion, preconditioning, and underground stope mining to optimize blasting for finer fragmentation. So we've been developing an energetics process that can create customized pressure pulse profiles, varying rise time, peak pressure, and pulse duration in both single and multi-pulse operations. So we're going to use the finite discrete element method modeling with a combination of detonative gas combustion preconditioning and blasting in phased boreholes, and run a number of sequences to look at gas pressure driven fractures, quantify the damage area, and then quantify the intensity of induced fracturing and fragmentation. And the results of this modeling and simulation effort will kind of feed a techno-economic model where we can validate ability to provide a network of fracture faces for blasting to interact with and enhance the resulting fragmentation before the rock's brought out of the ground. And then in the end, reduce the required blast holes and overall required energy to achieve better fragmentation.
Awesome. Thank you, Jacob. All right, Ray, are you on the line? I think I saw you put some comments and questions on there.
Holly, yes, on the line. We're a small high-techo consulting group. There's only a couple of us in it. We're interested in basically novel hydromet, particularly driven solutions for base metals, not competing with smelting, but much more focused on difficult ones, carbonates, oxides and sulfides with contaminants. Long history in base metal hydromet, some successes. This challenge is fascinating because the technology side of it, there's nothing there that's really available that I know of that's going to work unless we do something very novel. And I actually think the same about the next one, which is the chalcopyrite leaching. And Kevin, I've worked on it for 30 years. So I will put something into that as well. They're tough challenges, but we have to do something better and we have to get radically different. I think we just can't look at incremental improvements. We're not getting anywhere with those beyond what we're already doing. So, yeah, that's what we're trying to do. And look forward to being in this one. And we've got a novel roast, leach, precipitation type approach to it. Chemically, it makes sense. Practically, sorry, we don't know yet. That's about where I'll leave it.
Thanks, Ray. And I guess that's the point. That's the opportunity to test it, test that theory. So, and thank you so much for the context on the broader challenges as well. All right, Philip, are you on the line?
Yeah, find out how that goes. It's about an hour and a half.
Ray, you're on mute, I think.
Oh, Philip, are you on the line? You can see someone's come off mute. I can't see who it is.
Share more once I find out.
All right, I might come back to Philip, who I definitely saw was putting comments. So, Philip, are you asked to her?
Sorry, I'm here.
Okay, there you
Yeah,
go.
yeah.
We can hear you now.
Yeah, okay, good. So thanks, Holly. So I'm Philip Kwong from the School of Chemical Engineering in the University of Adelaide. So I'm very pleased to join this cohort for the essential minerals. So my team has developed a green recipient derived from biomass that can extract metals from different metal-containing resources, including the spent lithium-ion battery, copper, chromium, and arsenic timber. And now we work with the cohort here and the TED to evaluate whether that is possible to use our recipient for the ore minerals, for example, the liquid ore minerals. So after hearing from Kelvin on the copper, so possibly that we might try our recipient for the copper deposit as well, because we did some trial on the copper, chromium, arsenic timber, so with some good results. So maybe we can have a chat after, but I'm very excited to have our technology tried and work with the TED team here.
Thank you so much for that. And it's great to see there's so many connections across the different challenges that we have as well. And it's great to hear people thinking about these opportunities. Okay, Henning from Echion, are you on the line as well?
Yeah, I'm here. Good morning or good evening. So my name is Henning Prommer and I'm representing Echion. And so we are a very small startup. We only started a few months ago. And we are focusing on developing a new in situ recovery technology that we call electrokinetic in situ leaching. And so we essentially want to emplace electrodes directly into ore bodies and then apply a direct electric current. And then we use that electric field to transport lixiviants into an ore body, dissolve metals like copper or any other charged metals, and then transport it to a reservoir from where we can extract it. And so we have been working on this on a lab scale, and now we at the point where we upscale this and eventually want to go to a field trial. And we have originally done this mostly for copper with hard rock, but we have also within a TED challenge, we have also applied that to tailings, and that seems to work too. So I'll leave it with that for now.
Thank you so much, Henning. Really interesting technology. So everyone should go and have a look at what Echion are doing and all the other innovators as well. Okay, the next couple, I do have slides that I've been asked to share. So Adam, are you on the line to talk to the future element?
Yep.
Hey.
Everybody around the world. So I'm from Clean Tech Water and Future Element, which is a joint venture looking at ways to eliminate tailings dams around the world. And the way we're approaching this is with our ATA technology, which is a smart way of getting water out of tailings by using flocculants in a creative way, where we use 2 different size fractions, put complementary reagents on each of those, and then they stick back together again and make an agglomerate that readily releases water. So we've done this at lab scale, we've done this at small pilot scale, and the approach we're looking at here is to go all the way to so-called dry stacking, which is where you are able to deposit the tailings in a way that you don't require a dam to retain the water, because there's no water in there, they're not subject to liquefaction. So what we'll be doing is taking the prominent hill tailings and doing the amenability testing on that, and then doing some more in-depth dewatering studies, and then moving to a pilot scale implementation if everything looks good. Thank you.
Thank you so much, Adam. And last but definitely not least, Peter, would you like to come on and talk about your work in Rampart as well?
Hey, thank you very much. Some interesting projects that have been presented, and looking forward and working with all of you. In terms of Rampart is a small company in Langley, BC. We work on electric and magnetic field sensors applications. And in this particular case, we're looking at basically using electrochemistry to neutralize and extract or separate out ion-rich stream, basically. So the challenge that we're looking at was asked of us was to see if we could actually apply it to recuperate water for flotation or recuperate acid for leaching. And this is the kind of two flow sheets that we together. And our experiments, 3 basically. One is to demonstrate that on a bench scale that our electrochemical cell could not only neutralize acid effluent, but could also generate value from hydrogen and electricity. Experiment 2 is demonstrate on a bench scale our electric sieve that can separate a neutral metal-laden stream into a neutral clean water stream, and one that is that can be recycled, and a neutral metal ion stream that it can be sent off to subsequent processing. And the third one is to do the same, but now at acidic level, basically taking it directly and separating it out so that we can actually separate out a clean acid stream, and obviously process the remainder. That's it. Thank you.
Awesome. Thank you so much, Peter. And thank you for all of the cohort to come online. I think, you know, I was just reflecting as you were talking, like how globally distributed this cohort is. And I think that's a great point for those of you looking to join TED. Like, it really doesn't matter where you are around the world. And it's just great to see all of these experiments going forward. So that's the end of the formalities. So we still have some time left for some questions. I left this last slide on the board because I also encourage you to scan this QR code, and then you'll have way more links to more videos from more people in the ecosystem to find out what other people are doing as well. But I will stop sharing, and then if anyone else has any other questions, and please feel free to ask questions of the cohort as well. We'll come online and do that. I know there are quite a lot of questions in the chat around data, so I will just take those offline as well and see what we can share and follow up on those as well for everyone. And yes, you can access the recording. How we will send everyone that's registered, we'll send you a link. We'll publish this on YouTube in the next couple of days, and we'll send you a link so you can watch the recording as well. So I might ask, is any of the TAD team, Jess, Hashida, Kevin, anything else you'd like to add while people are putting a few more last questions in?
No, I will just touch on quickly the question that was raised in the chat earlier by Fernando, which is you can submit as many ideas as you want for any of the calls you want, or just generally, we are here to work with you to figure out what the best way to de-risk your hypothesis is and help to accelerate things. So I would be very surprised if all of you just had one idea. We're very happy to talk about whatever you'd like.
Awesome. And I love that question from Hayden, and I don't know who wants to jump on and take this, but Hayden said, I'd love to hear from the cohort participants, the experience of working with TAD, and what have been the primary value adds for you, and what have you found challenging. So I don't know who would like to come and talk about that. Otherwise, I don't want to pick on people, but go, Ray.
Hi, Hayden. I've been involved probably much from the start. I was involved in an initial challenge, which went through to experiments and a program on the treating copper concentrates, etc. So if you do want to actually ever talk about it, happy to do so. But my comments online there, it was very positive and some great interactions, and yeah, definitely good value.
Thanks, Ray. I'm not sure who has linked this automatic AI subscription, but I'm going to delete message. Awesome. Anyone else from the current or past cohorts like to share any of their experiences? I won't pick on you, but if you'd like to, please do. Thanks, Jacob, and thanks, Peter.
I'm hoping my sound is coming through.
It is.
Excellent. Just switching things. Well, I'm just going to jump in here to say it's actually been my first cohort as well, leading a cohort, or facilitating, I should say. And it's been a really cool experience for me personally to learn how we can work this way, but also to see how the innovators are all interacting with each other. I'm not going to lie, it's not been perfect while we've been going through all the teething issues, but every single cohort, at least from my perspective, we are trying to iterate and improve and I guess make the process as simple and effective as we can for you. And yeah, appreciate any feedback you have. So thank you.
Hashida. And I should probably give Hashida a bit of a plug, and I'm not sure if we can keep this. I might have to delete the comment, but for those of you who are on the current cohort, Hashida has been working incredibly hard in the background to navigate incredibly complex procurement and contracting processes, and to make your lives as easy as we can. But it's been a huge amount of work, so kudos to you, Hashida. I know that that stuff doesn't always come to the forefront, but I know you've just put so much effort into it.
Thanks, Holly, and for you and the Unearthed team as well. We're all here to support.
Yes. And as Hashida said, any feedback, I mean, I think we're always trying to improve experience, and so we're always really keen to hear from you about what could be better, what could be different. Hayden's also asked, how many cohorts have there been? I think we calculated 11 the other day, but that does cover quite a range. Jess, or Hashida, is there anything you'd like to share on some of the past cohorts?
I was rapidly trying to count in my head, so I'm so glad you had an answer. Look, Hayden, I think it's fair to say we've been finding our feet as a new combined force when TAD and BHP, Oz and BHP integrated into the new and improved TAD. And so we had quite a lot of cohorts at Oz Minerals. And then it took us some time to announce the cohort today. And so I'm just eternally grateful for the patience while we made sure that we had the right experience to deliver them when we announced it, because the last thing we wanted to do was make a commitment to someone and then not have anything to do with them. So I think the good news is we've got our blueprint sorted. We've got the right team around us. The capability of the global TAD team now is overwhelming. I mean, Kevin, you blew my socks off today. I was so just excited to see you engaging with the ecosystem. And so I think you'll see a lot more activity now that we've found a way forward. But it did take us a little bit of time. So that number slowed down and it'll ramp back up, I think, as we continue to work with the right innovators on the right work moving forward.
Thanks, Jess. Krishna, you wanted to come up and make a comment? You're still muted. We still can't hear you, but I'll just have a quick read of the questions that are coming through while you try and unmute. And thanks, Bernadette, for the experience in Sedgman.
Okay.
Yeah. Oh, there we go.
Oh, as an alumnus of this program, and one thing, so I didn't get the name of the person who was talking earlier, but I also want to kind of acknowledge that this has been a useful kind of platform for us, and our proposed process did not get into the next stage. This was with the ingenious extraction cohort, And my question was, is there an update on how bioleaching is progressing? And other than that, there were some other thoughts that I had or that I wanted to share with the group, that while I was at ASARCO, the company from which I retired, at one of our mine sites, we looked at PLS and found that for a student project and found neodymium in there, So basically, I think recovery, and the thought then was to have some kind of ion exchange resin in the system that will collect the rare earths and then have, have this cartridges in each leach system and then have a central processing facility to recover the neodymium, And again, this was just a senior student project, so it went only that far. And other things of interest are how do we, incorporate decarbonization as well. And I think with the leaching initiative, I think, if we are able to use renewable energy for, for the electrowinning process, that might be one way to tackle the energy situation by getting it and decarbonizing at the same time.
Thanks, Krishna. And sorry to cut you off there. We're just really close on time, and I think
Yeah,
all these ideas are great to discuss, and maybe we could discuss some of them offline.
I can probably make 2 closing comments if you want.
Yes.
So Krishna, we're in the final stages of review for the biometals and comminution challenges. So you asked about where we were with bioleaching. So stay tuned. That announcement will be coming shortly. And I really just want to acknowledge Clint, who I don't know yet, but I'm very interested to meet, because I really love the mix of how and what questions that are coming through in the webinar today. It fills my heart right up. We always talk about the what and how being equally important. And so the one thing that I guess I'll just close, because I know we're out of time and I respect everybody's time, is Clint's asked what, I'm sorry, is it Clint, or now my things are scrolling?
Hayden?
Sorry, someone's asked what the difference between the first challenge and sort of where we are today is. And I think the reason that I'm so energized and excited about being powered by BHP now is at Oz Minerals, we didn't have the resources that we have at the global scale here. And so when we do something great with an innovator, we often didn't have a home for where they could go next. It was a lot harder for us to scale. And that innovation pipeline that I put up during the talk that I did at the beginning really presents so much more opportunity for us to help people scale, no matter sort of what stage in commercialization they are, and to grow with them. And so to me, that's the big change that we've seen. And I'm really excited to continue to support people even further now.
Thank you so much, Jess. All right, we're out of time. So I just want to say a huge thank you for everyone for dialing in. Thank you to all our innovators who jumped on and spoke. Thank you so much to Kevin and Harshita and Jess. And yeah, have a fabulous day, morning, evening, wherever you are around the world. Absolutely loved the location shares. Thank you. And we'll share this recording. So thank you so much, and we'll see you next time.